This information doesn't necessarily immediately apply to implicit differentiation, but it is important. And now that we have all of our rules and all of our understanding of derivatives, we want to go back and take a look at that limit definition of the derivative real quick and make sure you understand how you may see it in the future. So this is the definition of the derivative. And you're going to need to be able to recognize that moving forward. And the reason is because you're going to be given situations that look like this. And at this point, while you do know how to cube x plus h, you could multiply all that out and simplify all of this algebraically. It would be important for you to recognize that what this is asking you to do is actually take a derivative of whatever the original function was. This limit is the definition of the derivative. So the question is, what was the original function? Well, the original function is here, right? It's f of x. So f of x plus h minus f of x. So 2x cubed would have been the original function that I am trying to take the limit of. So my f of x is 2x cubed. So if I'm trying to do this entire limit, what I'm being asked to do is find the derivative of 2x cubed. This is the way you're going to be assessed on understanding the limit definition of the derivatives in the future. So I do know how to take that derivative without doing any algebra work. I know that that's the power rule, so I now have my derivative set aside. So this is not necessarily asking me to do a bunch of limit notation. It's just asking me to find the derivative of that piece. Technically on this one, I do know how to cube that, but we are going to get to situations where we don't know how to manipulate it algebraically. So this is one of them. So I've got the limit as h approaches 0, cosine of 5 times x plus h minus cosine of 5x all over h. So I recognize this as f of x plus h minus f of x. What I did here was I took an x plus h and I plugged it in everywhere there was an x over here. So that's what this first term is. So when I recognize that, I can immediately come to and say, all right, that means that my original function was cosine of 5x. And because I recognize that as the limit definition of the derivative, I can say that I'm trying to take the derivative of cosine of 5x, which is a chain rule. So I would do negative sine of 5x times the derivative of the inside, which is 5. So my result, I always want to put that coefficient at the front, is negative 5 sine of 5x. So this result of this limit would be negative 5 sine of 5x because this is asking me to take the derivative of cosine of 5x. Now, we do get a little bit trickier when we start asking for numbers and evaluations at a specific point. One of the other definitions of the derivative that we looked at was the idea of plugging in a value where x was. So if I was looking for f prime of 2, I could take a 2 and plug it in right there where a is. So it's important that you understand you are not being asked to take the derivative of a constant. You are being asked to take the derivative of a function at a specific value. Remember, the derivative of any constant is going to be 0, but that is not what this question is asking me to do. I need to determine what the original function was. So in this case, that represents the x plus h part, right? Or in this case, a plus h, where I had a specific number, right? So if that's the case, then this should be sine of quote unquote x, but a in this case, which is sine of pi over 6. So sine of x was actually my original function. Please don't try to take the derivative of this. Again, that's just going to be 0. So my original function, before I plugged in any values and got numeric analysis, my original function was f of x equals sine of x. So what I'm looking for is f prime of x, remember that's that limit definition of the derivative, at x equals pi over 6. So you have to take the derivative first. So I do know the derivative of sine. The derivative of sine is cosine. And then I want to take that information and I want to plug in the value that I'm being asked to analyze. So remember that A value in this case was the pi over 6, right? So I'm looking for f prime of pi over 6. So that means I'm going to plug a pi over 6 in to my derivative. And cosine of pi over 6 is root 3 over 2. Now, I don't have an algebraic way to get to this from this. The manipulations are too complex. Okay, I don't have a way to do that. But if I can recognize this as the derivative of sine of x at pi over 6, then I can come up with the numeric analysis. So in the future, you're not going to be asked to do all of the, factoring and then eliminate and multiply by a conjugate and all those kinds of things. But recognizing this and recognizing that you are being asked to take a derivative when given this kind of limit is going to be important.